So I first came to Imperial in 2014 to study for a PhD. While I did my PhD, I definitely knew about Danny, but I never really met him because what I worked on was quite deeply theoretical and it was a bit disjoint from the stuff that Danny and his team were working on inside the labs, which was, I mean, fascinating stuff, and I always was kind of wanted to be able to go in and see what was happening in here. But it wasn't until I came back to Imperial later on in the role of a science communicator, and if you don't know what that is, that's kind of trying to share a passion for science with a wider audience. It wasn't until then that I was lucky enough to be able to call Danny a colleague. And what I wanted to do today was tell you just maybe 3 or 4 anecdotes about how I interacted with Danny in science communication and how he kind of left his fingerprints on what we were doing and the great experiences I had with him. The reason I'm showing you this video to begin with is you can see the way it's filmed. When I started off in this position, I didn't really know what I was allowed to do, right? Because I had some ideas for things to do that I'm not sure everyone would be happy with. But so I was quite worried. But Danny was amazing, right? He basically was behind it 100%, this idea of science communication. I mean, he let me into this world-class lab with a camera that I clearly had no idea how to operate, right? Like bumbling around, and he just let me get started, and he was so enthusiastic for it. And while I've got this up, actually, in fact, we're just about the right spot, I'll skip back a bit. If you ever want to know if someone's inherently like a great science communicator, or even just if they love what they do, watch them try and explain something without the sound on, right? So watch what Danny does with his hands while he's talking. He gesticulates like naturally, like completely, and he does it a bit more. I've watched this so many times, I know exactly when the bits come in. But you can see from the way he's talking to, I think at his time with students, I think, but I can't remember who was who now. He's getting into it. And that really says about Danny how much he was into science communication. I have to skip now because I break something in a minute. So, but you know, what my point is, he was super supportive of talking to people about science because he was so passionate. I mean, this is what he let us do. Is anyone here from the States? Excellent. Okay, so he not only let us, but encouraged us in an unliable way, to be clear, to build this ridiculous Rube Goldberg machine that we sort of destroyed one of the offices to do. He also let us and encouraged us to put on a magic show, which was possibly partly also because we'd all just wanted to do a magic show since we were little, I think. But he was behind us 100%, and that support was invaluable to me because it really made me feel at home. And that's one of the things, the general things I'll never forget. But more specifically, not only was he supportive, but he got involved in the outreach, the science communication we did. And I want to tell you about some projects in particular where he had a much more important input that I think says something about his creativity, his enthusiasm and his passion, and just generally how kind-hearted he was with this stuff. So the first project I want to talk to you about is a project that Sanya worked on, who I think's here, which is the Paperclip Ion Trap. Now, a lot of people will tell you that it's not a good idea to plug a paperclip into mains voltage. Fortunately, Danny was not one of those people. And so, let me start from the start. Of course, if you've ever spoken to Danny, you probably know a little bit about ion traps, right? Because Danny loves ion traps. After knowing Danny, I now love ion traps as well. And I think you all kind of got a good introduction from Richard, that the idea is that you can sort of levitate a kind of charged atomic-sized particle with a clever use of electric and maybe magnetic fields. And so when Sanya came to me with the idea that she wanted to build, for a science communication project, effectively a scaled-up version of this that doesn't necessarily trap atom-sized charged particles, but larger, like dust particles that are charged, I obviously went straight to Danny. And I thought Danny might just give some general ideas, some general input, but Danny really got into this idea in a way that I would say is borderline obsessive, but in the best possible way. So with Danny's help and his input and his guidance, Sanya managed to build this device, which used a paperclip, And I, every few days, would have a discussion with Danny just about how it was going generally and any ideas. And the sort of the detail with which I discussed a single paperclip with Danny has given me sort of an appreciation for stationery that I will never look back on. So here's the demo, all set up. And I'll explain a little more. I don't want to go into too much of the science, but I'll explain a little more about how it works, mainly because there's lots of people here who know ion traps really work, and I'm sort of in the lion's den as such. So in this box, you will see, if you look closely, that there's actually a little hole, and you can just peek through it and see that there's a paperclip in there. But it's actually two pieces of a paperclip. Each one's connected to a different wire that just very nicely goes into this orange lead that's plugged in. So one of them's on the live, one of them's on the neutral, and roughly speaking, the idea is that if you sort of put these two bits of paperclip to the mains, because you sort of oscillate at, I'm too nervous to get this right, 50 hertz, you maybe, you sort of change which one is charged, a certain charge, very quickly. So if you charge some metallic dust and drop it through, it will be attracted to one, then the other, so quickly that it really doesn't know where to go and it just sort of levitates. Very rough, very potentially bad explanation of the idea. And if you set this up and you shine a laser on it, then the little bits of dust will light up and you can just about see them moving about inside that paperclip trap. Now, there's a better video. Oh, there we go. Oh, that's a good bit. There you go. There's quite a few in it there. So, key to this was the fact that Danny gave us so freely his experimental skill to help this project happen. And I think there's no doubt that Danny had that, and his generosity with that was kind of crucial to us. I think this project kind of says that a lot, but I wanted to show you... Oh, there's a good bit in a minute. Okay, I wanted to show you another project that I think really says a little bit more about Danny's creativity. And that was another project, that I was lucky enough to have his input onto, which was building a cloud chamber. Now, doing science communication, I often would go into schools or to museums or even to the pub and want to talk to people about science. And when you do that, the thing you really want to be able to do is take an experiment or a demo and go up to a group of people and make it happen in front of them so they can actually, you take the science to them. And for a long, long time, I'd always wanted to be able to build this demonstration, which is called a cloud chamber, in a way that was portable and let me do that. Now, there are many ways you can build a cloud chamber. This is quite a sophisticated one, but they're all quite big. One component they all tend to need is like a fish tank or something quite big like that. And what a cloud chamber does is it lets you detect subatomic particles. And the way it lets you do that is really quite beautiful, because when you look at it, you see tiny trails that they leave that look a lot like a miniature scaled version of the kind of trails you might see behind a jet plane in the sky. So if you set up conditions just right inside this kind of fish tank, you can see that. And what's even more amazing is there's a tiny chance, if you're lucky, that one of those trails might be left by a particle that's a descendant of a cosmic ray that could have travelled over most of the known universe for billions of years just to get here to leave a trail. So it's obviously quite a good one to be able to just like rock out in the pub. But for a long time, I'd had no idea how you could do that because it's not very transportable until I spoke to Danny. And I was speaking to him one time, I forget where we were talking about this, and I sort of lamented to him, I always wanted to be able to do this in a more portable way. And he sort of thought about it for not even that long, and he said, well, why don't you just do it in a glass, right? Because the biggest problem with this is that you have to make sure everything's quite nicely sealed. But a glass is like inherently a sealed unit. The top's got a hole, but you can put that down and all you have to seal is the bottom. And after some thinking, came up with the idea that the best kind of glass for this would obviously be a pint glass, right? Because then there's another part to the experiment and the preparation becomes more interesting and fun. So in one foul swoop, it was a lot more possible, right, for me to do this. So I went away, I played with it, I kind of got it working, but it was still tricky because you also need another thing to get this to work, which is to make the bottom of it very cold. So cold that normal ice won't do the job. You need to use a special kind of ice called dry ice, which is frozen carbon dioxide that maybe everyone here knows. And that's not easy to make, or not very fun or easy to carry around. So I remember speaking to Danny again about this. I've got this far of it. I think it might have been in the first year labs, I can't remember. But I got this far with it, but I'm not sure I really want to carry around dry ice. And again, after sort of thinking not that long at all, Danny came up with the idea of, which I will not say he's liable for me doing this, fire extinguishers, right? Fire extinguishers produce carbon dioxide, right? And it actually turns out there is an attachment that I got hold of that I can put onto a fire extinguisher and produce dry ice on demand. Scares everyone to death, but no one's got injured yet, so it's all good. But the point is, like, this is not just an ingenious way to do this, it's creative, right? What makes this demo for me now, it's one of my favourite demos, is the fact that it's specifically the fact that it is a pint glass and it is a fire extinguisher that I use, because it's such a creative way to do that. And that's the kind of input that I think is completely invaluable in science communication, and says that someone has that spark, that sort of twinkle for doing it. I do have, I have a video. So this is it all set up. There's a torch on it so you can see what's going on. And if you look carefully, I've got a laser pointer, you might see there's a trail. So if you watch carefully, you'll see the trail of the subatomic particles. I think the one comes, there's one. There's one. It's quite addictive actually, because and then someone's come up in the leftish side, I think, in a minute. Oh, there's one. Oh, there's one, there's a big one. So it's kind of hard to do, because when you do this in front of other people, like, they might be sort of looking and you're, shh, there's one, and they don't see them, but you don't care because you're just enjoying it. Okay, that was another example of a project I worked on Danny with. I wanted to say a quick thing about another experiment we did that with Danny's sort of allowance, in a sense that you'll see in a minute. Because I've already said a little bit how sort of, kind-hearted he was, but in case I haven't convinced you, I want to show you just how generous he was with not only his skills, not only with his time, but also with his very expensive lab equipment. Because I don't know anyone else. I've worked with a lot of labs throughout the UK doing like science communication things, and I can't think of anyone who would more readily or enthusiastically as Danny have let us use his super expensive laser setup purely and solely for the purpose of trying to, and this is Graham who I think is here somewhere, there he is, purely for the purpose of trying to creatively pop a balloon. So what you can see is there's a black balloon inside a green balloon, and the laser's green, so fingers crossed what should happen is that instead of the, yes, it pops. So instead of the green balloon popping, the black one does. But the thing is that this is not something I would be comfortable to ask anyone to let me do in their lab, apart from Danny, because he got it, he had the enthusiasm to do it. And the final anecdote I want to tell you says something about Danny, so what I'm trying to say is Danny's not as directly involved in this demo as such, in that his expertise wasn't really part of what made it work, but it says something about Danny that is the thing I most aspire to be like Danny, that he most inspired me like, and that I think is just amazing. And this is a demo. This is the point at which I never get another job again, though. And this is a demo in which me and another student one weekend were messing around trying to set something up for a music festival we were going to. And we wanted to do this demo that we were really keen on. And somehow, why and how is not important, who's legally liable is not important either, but we ended up in a certain building in Imperial with an unexploded dry ice bomb, which is regrettable. We were basically looking through the window, and it was only at that point one of us said, what happens if it doesn't go off, which it didn't. And we were understandably very panicked and confused, and at that point, there was only one person who was approachable enough that we both looked at each other and we were like, well, if we're going to tell someone, let's tell Danny. And the point I want to make with that is such a thing, to be that approachable, to be that, So Danny knew by the way, it was fine, we diffused it. It actually turned out it had been diffused the whole time, so, which is, I don't know if that's more embarrassing or better, I don't know. But the point is that, there are many reasons you would want to talk to Danny, right? Because of his skills, because of what he knew, his knowledge. But the reason that I always, as well as those, that I always wanted to talk to Danny was because of who he was. I just wanted to talk to Danny, right? He was a lovely person to talk to, and he was so approachable. And that is the thing I aspire to most. And if I can be 1/10 as engaging and as approachable as Danny was, then I think, wow, I'll be doing okay. To finish that, sorry, that sounded like the end. It is kind of the end. To finish that, I was going for old videos where we made promo stuff, and I found one outtake where, the last thing he says in this little clip really, I think, sums up how he made me feel about what he thought about science communication and just science in general. So it's a bit rough around the edges because it was an outtake, but I think it says what I want, what I think I feel he felt. So thank you very much, and I'll leave you with that. Hopefully it's loud enough.
Imperial College is a great place to do research. It's extremely well funded. You get a chance to get your hands on some really interesting pieces of equipment and play with them and have fun. And what you should emphasise that's a large chunk of what you should be doing if you're having fun.
Thank you.